Before we start off with the chapter itself, let's look into few things that we have already learned. Starting off with the set of symbols. N stands for natural number, Z integer, Z plus positive integer. This is rational which is positive. So 0 is not included in that, right? Then we have real number, positive real number and irrational number. Then we also have the following: belongs to, does not belong to, a null set, a proper subset, a subset or equal to. We have not a subset, implies, double implies, union, intersection and complement of A. All of this PDF and everything will be available to you guys. Please see to that you download, take a print. So all these are from your 11th grade. So you need to remember all this, recall all this. Now, next thing that we need to understand is Cartesian product. So Cartesian product is a set of, relation. Actually, set of elements that have been related. So these are all binary, that is, you're relating two things. So we have set 1 and set 2, they are going to be related. So every element over here is going to be related to every other element over here. So this is known as your input set and that's your output set. As you can see, the input set is on the left and the output is on the top, and we generally do this. So as you can see, every element is related to every element over here. So A,1, A,2, A,3, A,4 is a possibility. B,1, B,2, B,3 and B,4 is another possibility. So this is a Cartesian product. So we need to know that Cartesian product is not just, that. Here, what I'm trying to show is there's a difference between having set 1 as input set and set 2 as an input set. So set 1 and set 2 will remain the same. So our output will look like this. Remember, we are relating set 2 to set 1. So this is our output. If you guys remember there, first very difference is the rows and columns are different. The elements in the rows and columns are different. And we go to each of this outputs. We have 1 and 2. 1 and A, 1 and B. There we had A1, A2, A3, A4. So here we have the numbers as the input and the letters as the output. That difference has to be very clear. So we'll make a small note over here that A cross B is not the same as B cross A, when A and B are your sets. Now, after Cartesian product, if you guys remember, we learned about relation. So Cartesian product is pretty much relating every element to every element, but we don't want that, right? We don't want this. So out of all of this, we need to select few. End of it, it's about filtration. You want to determine whose account is what, where the transaction is happening, or you want to basically end up with a particular set of elements, a particular set of output, provided there is a condition set across. To do that, we need to make use of relation. We define a condition. You know what? Out of all this Cartesian product, out of all of these elements, I want to have this set of outputs which follow this particular condition. The condition over here is we need A and B, the order pair, where A is from set A and B is from set B, and A, when A is divided by B, the remainder should be equal to 0. That's what A modulus B double equals to 0 means. So here the set 1 and the set 2 remains what we saw in the previous video, 8, 12, and let's think of it before I show it. 8 and 2, will it be related? When 8 is divided by 2, we get a remainder of 0. Yes, it is related. 8 and 3, no, we don't get a remainder of 0. So I have indicated that with an highlight. So you can see the ones which are selected are highlighted. So out of all of this, selecting few elements from a Cartesian product is our relation. Okay, so relation is a filter. Filtering the order pair of a Cartesian product, right? selecting few elements, or sometimes of course we select all the elements, sometimes we don't select any element, and sometimes few elements. Now we can define the relation in two ways. One is set builder form, another is row state form. So when we talk about set builder form, it is to write in this manner. So we are not exactly writing what will be the output, we are just defining the condition. So this is very useful when we are programming. Right? I can always see, or I can always change the input values, which I'm going to show you guys, and the output values, and define all of this, and the same program will give me a different set of output, but with the same animation. I don't have to hard code anything. It makes my job a lot easier. So it's very important for us to understand the row state form, right? So sorry, that is set builder form. Now the row state form of the same would look like this. R is equal to 8, 2, 12, 2, 12, 3, then we have 15, 3 and 15, 5. So that would be your row state form. Now domain and range, or pre-image or image, and codomain. This three set of terminologies too has to be familiar. For that I'm going to use the same definition. A is divisible by B. I've written it in a different form. The input set and the output set are the same. I'm going to represent this in a different manner. So we have 8, 12 and 15, 2, 3, 5 and 7, the same set of elements. Just that I'm going to represent it in a different manner so that it's easy to discuss. So basically we generally do this. And generally we end up writing the name of the sets and the letter whichever the relationship is defined as, in this case R. So the terminologies that we need to understand is the following. This is your input set, that is all these elements are part of your input, so they are known as domain or pre-image. The elements which are part of your output can be part of your output is your codomain. The elements which are actually part of your output, they have a different name. Here only 2, 3, 5 is being related. 7 is not related to anything. So 2, 3, 5 is called as image. One more name is range. Okay. So those are your domain, pre-image. Pre-image I wrote. Range and image, codomain. Yes. Codomain relates or includes all the elements which can be part of the output. Image or range are the ones which are part of the output. So this are your input set and those are your possible output set. Okay, so the same thing if I had done set 2 cross set 1, things would have been different. So we have pretty much finished this as well. One statement. A function or a relation R's image A is Amit. In this case, let me put it in this way. R's image of 8 is 2. That is, if I give an input of, this is your input, this indicates input. If I give an input of 8 for the relation, I'll get an output of 2. One last thing, when does a relation become a function? Right, here we have a relation. All functions are relation, but when will a relation become a function? So the same definition, but for a different set of inputs, I'll show you guys that relation becomes a function. The same definition, but the sets are different. So you can see that C will be related to 3 will be related to 21. A similar definition, not the same definition, similar definition, divisibility. And we have the following output. 3 can divide 21, 5 can divide 55, and 8 can divide 128. There it was other way around. But point here is, for every input we have an output, and every input we have a single output. So a relation becomes a function with the following condition. For every input there should be an output. For every input there should be a single output. Even though the output is pointed to the single value, doesn't matter, but it has to be a single output. So here we can see that for this is not a function clearly, because for this input we don't have an output, and over here for this input we have two outputs. Okay, so all of this is available to you guys. Please see to that you download this, take a print and revise it. Okay, so we pretty much, yes, we finished everything.